Hello class, I'm Dr. Yang and welcome to cs370 Operating Systems. Pthread library. Let's talk about the real stuff. Okay, we already talked about pthread before. It's the name of standard that's for the Unix-like systems. That includes Linux, obviously. Pthread library includes mutex and condition variable. And the thing is, the behavior of pthread mutex and condition variable is just like the mutex and condition variables that we studied so far. So this means the semantics and all the user's guide and best practices that we learned about mutex log and condition variable equally applies to this pthread library mutex and condition variable. Pthread library, this P stands for POSIX. POSIX looks like the acronym, but I don't know what those letters stand for. This POSIX is a standard body in early 90s and mid 90s that tried to standardize some of the Unix features. So as you may know, Unix is not just a single operating system developed by a single body. Unix refers to multiple different operating systems that follows the behavior of original Unix implementation. So, all right, the pthread library, let's talk a little bit about the history of pthread library. So this pthread library was developed in early 90s. Early 90s to mid 90s, and this is a standard. It doesn't come with any implementation, so people get together and write some of the standard language, and then they go back to their own company or their own operating system implementation, and then they each develop their own implementation that should be compliant to this pthread standard. And this pthread library was using C as its interface. So technically, pthread library is not part of the C. And that was the situation until year 2011. There's this thing called C11. So ISO is the international standard body, and somehow they got involved in standardizing the C language. And the year 2011 standard of C language actually managed to include thread idea. So if you're using the C11 threading, then you need to include, I think it's a thread. Threads, I think there's a S at the end. And the names are a little bit different, but essentially C11 interface is actually very, very similar to what's been defined by this previous pthread library. And if you want to use this original pthread interface, you need to include, I think it's a pthread. Okay, and also because this is not part of the C language, you have to actually tell the compiler to link the pthread library. But if you look at the C11, they are pretty much identical. So what's available in C11 is already available pthread. So, and the C11, not many compilers support C11. And that means if you want to write code that's for old systems, then you just stick to pthread library. So you may ask at this point, this is a good opportunity to talk about beyond C. What about other languages? Do they have this mutex and condition variable? The answer is yes. So for example, Java has classes for mutex and condition variable. And obviously, the rules and the semantics of Java mutex and condition variable follows the rules that we studied earlier. So the same rule applies. Okay, so the same rule for superiors to wake up, and same rule for condition variable signaling behavior, and so on. And also Java, as part of the language, all object can be locked essentially. So there's a keyword in Java called synchronized. And if you apply the synchronized keyword at the start of the block, then the mutex, hidden mutex of that object will be acquired at the beginning automatically for you and will be released when you exit the block. Right, that's the Java. And how about C Sharp? Okay, this is a Java-like language, and C Sharp is the same story. Okay, so they have C Sharp has, I think they named it Mutex, but C Sharp is developed by Microsoft, and Microsoft tend to define their own weird names. So instead of condition, so they have a class called monitor. And this is C Sharp's condition variable. Funny thing is, the monitor, if you're using monitor, the weight is named as, I think it's a weight, still weight. And the signal function is named pulse. And broadcast is called pulse all. So the thing is, different names, but essentially the idea is about the same. So the moral of this story is, if you have a good understanding of the behavior and the semantic of this lock and condition variable that we studied, and also if you know the behavior of pthread library, then it is very easy to apply to different platforms and different languages. Right, pthread RW lock. Okay, so now we are talking about this pthread, the original one, not the C11 interface. All right, so this POSIX pthread library actually comes with its own reader-writer lock. So that means the library gives you its native reader-writer lock, so you don't have to implement your own reader-writer lock. So if you need a reader-writer lock, just use this pthread reader-writer lock. And this is the function prototypes. All the functions are prefixed with pthread. One interesting thing is, this is the reader lock acquisition and this is a writer lock acquisition. But this pthread reader-writer lock uses the single unlock function. No matter what, doesn't matter. If you want to unlock it, just use this single interface. So that's the difference from textbook implementation of a reader-writer lock. So before we move on, let me just talk a little bit about this restrict keyword. This is a C stuff, okay? And this is a keyword. You may wonder, what is this, first of all? And so basically, this restrict is a new keyword added to a recent version of C. And this keyword implies that these two pointers, so reader-writer lock, which is a pointer of this type, okay, and we have attribute, which is a pointer to this type, okay, so this is pointer because you have these stars. And the restrict keyword here implies that there is no overlap between the pointer that's pointed by RW lock and the memory that's pointed by this ATTR. And that's a sort of obvious, okay? But the thing is, you have to let the compiler know so that the compiler can safely assume that there is no overlapping. Basically, this is for you to tell the compiler that it is safe. Compiler, it is safe to assume that there will be no overlapping between memory area that's pointed by these two pointers. So if you let the compiler know of the fact, then the compiler can pull some additional optimization trick. You have to let the compiler know Otherwise, the compiler cannot make that assumption without breaking something. And that means, as a user of this function, you need to make sure that these two pointers have no alias. So the memory region pointed by this RW lock and the memory region pointed by this ATTR should not have overlap. Okay? Usually that's not a big deal. Okay? So it is actually quite difficult to create those pointers to have an overlap. Okay? If you're writing code in any sane way. Okay, just like reader writer lock, pthread actually comes with its own synchronization barrier, and this is the interface. This pthread barrier wait is the name of check-in function that we implemented. All right, GNU Linux C library implementation. As I said, the pthread is a standard and the implementation is dependent on the implementer. Okay, the standard came about in mid-90s, and around that time, specifically for Linux, initially there were two branches, and one is known as, I think it's a Linux thread. So one attempt to implement pthread library, and the other one is known as NPTL, Native Pthread Library. Okay, and the thing is, these were the competing implementation in I think the late 90s and early 2000s, and eventually Linux thread died out, and I think it's abandoned like many years ago, and the NPTL became the standard Linux implementation. All right, so the one thing about NPTL implementation is it was implemented along with not only glibc C library, but also it was developed with kernel thread implementation of Linux. Okay, so at the time, around the late 90s, Linux was trying to become PC, personal computer clone, x86 clone of the Unix implementation, and those guys took this opportunity to implement the real kernel level thread in Linux. Okay, and so at the time, along with NPTL, Linux kernel was enhanced to support in-kernel thread, and along with it, they developed a new system call to deal with mutex calls and condition variable wait calls, and they developed this interface, system call interface, that allows user level thread to block and wait in efficient fashion. It's called Futex. This is the name of the system call. So you can literally look up the system call table and you can see the entry called Futex. Okay, so Futex is short for fast user level mutex. I will just mention that this Futex system call is very delicate. It is very hard to not only understand the behavior of the Futex, but also it's really hard to use, difficult to use. This is one of the area where you cannot actually extract the big picture from the detail. The details is everything, and the Futex implementation is so delicately cut. And Futex implementation has to be delicate because this is a kernel. Let's say this is a kernel, and this is a user. When user level thread, you're executing in user level, you want to make sure that most locking and waiting should happen inside user level. Okay, so you don't want to cross user to kernel unless it's absolutely necessary, because crossing user to kernel has a lot of performance penalties. So many fast case scenarios, such as trying to lock a free lock so you don't have to wait, should happen entirely in user level. And if you have to wait, or if there is a possibility of waiting, then you need to make sure that you cross the kernel, and so that the kernel scheduler needs to be involved, because the concept of thread is actually implemented in kernel. So the scheduling activity and putting thread to sleep or to block a thread should happen inside the kernel. So you have to make sure that certain events triggers user to kernel. So this is a very hard requirement to implement the system call. So that's the reason why this Futex system call looks very difficult to use. All right. Now, I already talked about C11 thread. So in particular, in Linux, the C11 thread is basically a wrapper around NPTL. So NPTL is part of the glibc, which is the default C library of Linux. So if you're writing multi-threaded application, I would just use pthread. The source code of the NPTL is available. This is a link to the condition variable wait function implementation. If you look at the code here, you will see more comments than the code itself.